Hello, I'm Brian Bush from the Marlowe team, and I'm going to be talking about using the Marlowe CLI to run contracts with the Marlowe backend. So in the previous lecture segments, we were using the CLI to either simulate contracts or run contracts connecting just to the node. If you're using the Marlowe backend, that gives you more capabilities, um, and it'll do things like manage wallets, organize UTXOs, balance transactions, and higher level things like that. You may have noticed that in the earlier lecture segments, we had to manage the UTXOs ourselves. We had to type in the transaction hashes. We had to make queries. So when you're using the Marlowe backend, you don't have to do that. So this has a number of components. The Cardano node lets you interact with the blockchain. Cardano wallet lets you interact with a wallet. The Plutus chain index lets you query historical and current unspent transactions and Plutus data, so you can query addresses, query transactions, and get information. And then the Marlowe backend will build Marlowe transactions and support the progression of Marlowe contracts. These components were designed for use with Marlowe Run. So Marlowe Run has its own backend components. And then just for completeness, we'll mention that the Playground has backend components too. So how are these deployed? Basically, we have a number of services that are running and they're all talking to each other using either HTTP REST calls or WebSocket messages. So the rectangles here are the different services. So we have like the Marlowe backend, the wallet, the chain index, the node. So these are all working together in concert. Fortunately, you do not have to set all that up yourself. There's a simple way to launch these services. If you're in the Marlowe Cardano repository and have opened a Nix shell, you can just say start Marlowe run. That'll launch all these services and they'll get synced with the blockchain. Furthermore, if you actually want to use a web browser and run Marlowe run locally, not with the Pioneers deployment, you can do an npm command to start the front end. So there are a lot of details about configuration and how to set this all up and how it actually works. I'm not going to go into that now, but I just wanted to mention that you can even run Marlowe run locally. So it's a little bit unfortunate that the word contract is used in multiple ways in the Cardano ecosystem. In the Marlowe backend, contract has a different meaning from normal Marlowe, where you're making Marlowe contracts. A contract in the backend is really just a group of endpoints for the web service. And we have three of those: the Marlowe app group of endpoints, the Marlowe follower endpoints, and then wallet companion. The Marlowe application contract and endpoints are very much like what we did before in the previous lecture segments. We create, apply inputs, move a contract forward, or redeem, withdraw funds. So these are very similar operations. These are on-chain operations that occur with the contract. And the Marlowe app actually supports that through these backend services. So the payloads for these calls are basically JSON that closely corresponds to what we saw before in the previous lectures. The response is pretty simple. If you're creating a contract, you get a copy of all the parameters. If you're doing anything else, you get a simple acknowledgement that it occurred successfully. So the follower contract and endpoints, I should say endpoint because there's only follow, is a passive watcher of the blockchain. So it doesn't submit transactions or use a wallet. What it does is discover history of what's going on with a particular contract. So when you first call follow, you give it information about the contract you want to follow, and it will respond with a WebSocket message that gives you the history up to that point. And so that's the parameters for the contract, the datum that contains all of the state and the contract and inputs and stuff like that, the history of inputs, where the contract is located, and then if there are any funds that need to be redeemed from the contract. So that's the history. You get populated. Anytime a new step occurs in the contract and that's recorded on the blockchain, you'll get another WebSocket message with an update of this. So this is how you can, in a decentralized sense, know what's going on with the contract. There's also the wallet companion contract that is quite simple. It doesn't have any endpoints, and it's also passive. So it's not watching a particular contract, it's discovering contracts. So when your wallet receives a roll token for a Marlowe contract, the wallet companion will actually send you a WebSocket message saying, hey, you're a party to a new contract. And then it gives you a list of all the contracts you're party to and the current data on those. So how do you use this? The CLI has help, and basically there are commands for each of these groups of endpoints. So we have create, apply inputs, redeem under app. Follower has follow, and companion doesn't have an endpoint, and then we have a command to actually stop things when you're done using these instances. And so we're going to run a simple contract on the back end. We're not going to go into the details of the follower and the companion. We actually have a tutorial that goes into all of that, shows you how to use them. It also shows you what log messages you should expect from all the other services if things are running correctly. But we're just going to do something really simple here. And a very simple contract is one that just receives a deposit, waits for a notification, and then it pays things out. And we're just going to create that by hand using JSON. So here's a JSON file. It's got a deposit, it waits for a notify, and then when it closes, it'll be paying out. And there's only one party here. It's a role named PAB, and that's basically it for this contract. Now, to use the back end, we actually have to have a wallet set up. So that means we have to give it credentials. So what we're going to do is restore a wallet there for the seed phrase that we were using in the previous lecture segments. So I'm going to create a JSON file here, and then we're going to make a curl call to the endpoint of the Cardano wallet. We're going to give it this information, and then it gives us back a response saying, yes, it did this. It gives us the ID of the wallet. I actually already pasted this in here. Now we can find the address of that. So here's the address of that wallet. And then I already funded it, but if it hadn't been funded, we could send ADA to it so that it can run. So now we're going to start the Marlowe app. And this is pretty simple. Basically, we tell it where the Marlowe backend is located in terms of its URL. We tell it the ID of the wallet we're using, and then we ask it for two things. When it creates the contract, we want it to store it in this parameters file, so we have a record of what was created. We also want a record of the unique identifier of this contract instance Marlowe app, because we're going to interact with that later. The backend might be managing quite a few different instances, so we need to be able to identify the correct one. So there, we're starting it. We're actually going to leave this running in the background, and we're going to say loop, because what's going to happen is we're going to be receiving WebSocket messages, and we actually want to not exit this command. We want it to keep running over and over again, just consuming all the WebSocket messages. So we're going to run this in the background. And then creating the contract is quite simple. Once again, we use the endpoint for the web services, the URL. We tell it which instance we're operating on, and then we give it our contract file. And then, as you remember, the contract had a role called PAB. We have to tell the backend what address corresponds to that role, because there's an association between role tokens and addresses. So basically, when the minting of role tokens occur, it's going to go to this address. So we're going to launch that, and we have to wait. So we're going to wait. And so this responded pretty quickly, actually. And so what we have here is the response that says endpoint success. It says create response, and here's the payout validator hash and the role token currency that was just minted. So this basically tells us what we need to know about the contract. And then it also says that it's ready to accept calls to its endpoints again. Up here, when we first did the creation, it said, no, you can't call anything. Now we have all these available. So we're going to make a deposit. We can take a peek at these parameters as we saw before. Like I said, it just has the validator hash and the currency symbol for the role tokens. When we apply inputs, we are connecting to the back end, telling it which instance we're dealing with, and then we're also telling it which contract we're applying the inputs to. So we have that extra information. The deposit is just going into this account for the role PAB. It's 15 ADA, and then we have a time range for validity. So we're going to run that, and we need to wait a little bit. Okay, and now the next step is simply to notify the contract that it's time to pay out the funds. So this is very much like the previous command, except now we say notify, and we'll just do that. And then we're going to actually wait again for the transaction to be confirmed. Okay, the transaction is confirmed, and then we're going to withdraw the funds. We use this redeem command. It's very simple. It knows which addresses or which wallet is being dealt with, so it's basically just redeeming for that wallet. So you have to give it very little information. That running, and then we're going to have to wait a little bit for the transaction to be confirmed. And then so we have success again with the redeem response. So we're done with the contract. We've put in the funds. We withdrew it. We're going to stop the PAB. And then I'd just like to point out there are other operations here related to the back end. We have testing facilities, so you can actually do scripted tests of contracts that interact with the Marlowe backend. You basically give it a sequence of operations, and it will perform them one after each other, and then waiting for the confirmations between the transactions. And we have a tutorial on how to use that. And we have some test cases you can use. So in terms of troubleshooting, everything from the previous lectures apply. If you're doing anything custom with the back end, you've got to get all the ports and things, firewalls, all that stuff configured correctly. If you don't have enough funds in the wallets, of course, you will have failures. Their log messages are pretty self-explanatory. And we also have a test suite where you can actually test your deployment. So basically, the key to debugging when you're using a backend is to, look at the log files, really see what's going on, see where things are breaking, see if it matches your mental model of what should be happening. In terms of resources, it's really everything we've talked about before, except for the test suite we've talked about and the example of using the Marlowe backend. So these exercises are optional. If you really want to tackle using the back end, we have that extended tutorial. So that would be one thing to actually work through, use the follower, use the companion. And then you could also try running the back end tests yourself, and you should be able to see all the transactions occur for these quite complex contracts. The tests involve swaps, escrows, covered calls. So there's quite a bit of contract there. In summary, we've got this Marlowe backend. We've got 6 components working together there. The PAB command lets you interact with that backend I didn't go into it, but there's also a query command where you can query the Plutus chain index and see what is the current state or even the history of a Marlowe contract. And then we have this test facility. So thank you very much.